In order to help you understand the rule for adding and subtracting decimals, it's important to look at the difference between addition and multiplication and what we always find that we have to do when we add and how that's different than what we do when we multiply. Right? So on this document, normally we'd be taking notes on this together in class. So over on the addition side, when we compare the two, addition we talked about earlier in the semester as the union of two sets, all right? Whereas multiplication is repeated addition, all right? And here is something incredibly important that I'm calling your attention to. Whenever we add, right, you must have like units and you keep those units. And this is true across all of the things that we do across the entire curriculum. So I like to point out that math is not just hundreds and hundreds of different rules, right? It's just a few rules, but applied slightly differently from topic to topic, right? But whatever it is that we're adding, we always have like units and we keep those units. In multiplication, the fundamental difference here between adding and multiplication is we never need like units, and the units change. The units get multiplied also. So let's start right in with whole numbers. Remember, to add whole numbers, right, you add ones and ones and get ones, okay? We add tens and tens, and our answer is in tens. So we only add like things, where in multiplication, right, we have to multiply every place by every place, right? So I could think of this problem as FOIL, right? And we were just doing that the other day with mixed numbers, right? When we multiplied mixed numbers, we found that we had to FOIL. So every time we find ourselves wanting to multiply, we have to multiply every place by every place, right? So this would be a FOIL problem, right? Which I'm showing right here with the arrows. And notice if I multiply tens by tens, I don't get tens, I get hundreds. All right, so the units change. All right, so that's true in whole numbers. Then we go on to fractions. All right, and in fractions, we have to have common denominators. So there's our same unit, right? The common denominator. If I add fifths to fifths, I get fifths, okay? Or if I'm adding mixed numbers, right? I add the whole number part, I add the fraction part, right? This should kind of remind you of what I just saw up above, where I just add these two and just add these two, right? But if I'm multiplying, as we just saw the other day, multiplying mixed numbers where we had to FOIL, right? Everything has to get multiplied by every other place. All right, so this should look just like it did with whole numbers. Okay, and when I multiply, I don't need common denominators, right? Fifths can get multiplied by thirds. My answer is 15ths. If I do have a common unit, if I multiply fifths and fifths, my answer is not fifths. My answer is 25ths. Okay, so the units have changed. Right, so this is exactly what happens with decimals, right? So our rule for decimals is line up the decimal point, add, and bring things straight down, right? So like notice in this problem, I attempted to add tenths to hundredths, right? We know that that doesn't work, okay? So we have to line up the decimal point so that tenths are added to tenths, hundredths are added to hundredths, ones are added to ones, right? Whereas in multiplication, we don't line up the decimal point, and we'll go on and talk about the rule for multiplication in a few minutes. But again, we have this same idea of every place has to be multiplied by every other place, all right? And then we'll adjust the decimal at the end, and we're going to learn how to do that in the next clip. Okay, so we move on from decimals, we get more advanced, and we go up into algebra, right? And in algebra, must have like terms to add, right? 2x plus 3x is 5x, right? Whereas 2x times 3x would be 6x squared, right? The unit changed if I did that. Okay, so we have to have like terms to add. We keep those terms. And but to multiply, we don't need like terms and the units change. And then this is also true in radicals. And boy, I see an awful lot of times students try to say that's radical 4 and this is radical 5. But when we're adding, the radical 2 is our like unit, right? So this is 1 radical 2 plus 1 radical 2, which is 2 radical 2. And I can't combine these because they're not like terms. Okay, I can only combine in addition if I have like terms, whereas I don't need like terms to multiply. All right, so same exact rule applies all the way across the curriculum. All right, so I hope that I have helped you throughout the semester see some common threads that permeate the entire curriculum. And this is certainly one of those common threads, right? That adding anything, whatever it is, starting in whole numbers right on up through algebra and high school math, we need like terms to add. We don't need like terms to multiply.